everyone. I am Dr. Vivek Saxena. In this lecture, we will cover the topic voltage and current sources in our subject Fundamentals of Electrical Engineering. What is source? Source is a device which converts mechanical, chemical, thermal, or some other forms of energy into electrical energy. Hence, we can say that the source as an active network element means for generating electrical energy. The main categorization of voltage and current sources are, as you can see here, sources can be categorized into mainly two categories. First one is voltage source and second one is current source. After that, voltage source and current source can be subdivided into two categories. First one is independent voltage source and second one is dependent voltage source. Similarly, current sources into independent current source and dependent current source. Further, we can subdivide in these categories into two categories also. As you can see, independent voltage source can be categorized into two categories. First one is ideal voltage source, second one is practical voltage source. If we talk about the dependent voltage source, it be categorized into two categories. First one is voltage dependent voltage source and current dependent voltage source. Similarly, we can say for the independent current source, it can be subdivided into two categories. First one is ideal current source, second one is practical current source. And dependent current source can be subdivided into further two categories. First one is voltage dependent current source and second one is current dependent current source. Now this one is the categorization chart of various type of electrical sources. Mainly, we can subdivide the source into two categories. First one is voltage source and second one is current source. The unit of a source is given in terms of voltage, then this one is called voltage source. If we talk about the current source, if the unit of a source is given in terms of ampere, then it would be called as a current source. Now, the source, you can see here, the source whose unit is given in volt is known as voltage source. Example, battery and generators. It can be subdivided in two categories as we already discussed in the previous diagram. It can be subdivided into two categories. First one is ideal voltage source and second one is practical voltage source. Ideal voltage source and practical voltage source comes under the categories of independent voltage source. Now, ideal voltage source and ideal voltage source is a two-terminal circuit elements that maintains a constant terminal voltage no matter how much current is drawn from it. As you can see, this one is the symbol of a ideal voltage source. Vs is the voltage level of this voltage source and A and B are the terminals of this voltage source. V0, we are considering here the output voltage and I0 is the output current. This one is the Vi characteristic of ideal voltage source. As you can see here, in this characteristic, output voltage remains constant at any value of output current. It means at any condition, ideal voltage source will deliver a constant voltage level. The next property of this ideal voltage source is the internal resistance of ideal voltage source is 0. If we talk about the practical voltage source, then the output voltage cannot remain constant at any value of output current. As you can see here, a practical voltage source consists of an ideal voltage source in series with an internal resistance. As you can see here in this symbol, this one is the practical voltage source. Vs is the voltage level of the voltage source. Rin is the internal resistance of the voltage source. I0 is the output current and V0 is the output voltage. If we talk about the characteristic of practical voltage source, you can see here by red color, we have plotted the characteristic of practical voltage source, and the dotted characteristic is showing the characteristic of ideal voltage source. In the ideal voltage source, output voltage remains constant at any value of output voltage, while if we talk about the practical voltage source, then the output voltage will decrease if we increase the output current. Now, this one is ideal current source. An ideal current source is a two-terminal circuit element that maintains a constant current no matter how much voltage is exists across its terminals. As you can see, this one is the symbol of ideal voltage source. Is is the level of current that it would be delivered. I naught is the output current. V naught is the output voltage, and A and B are the terminals of this ideal voltage source. As you can see, the characteristic of ideal current source, output current remains constant at any value of output voltage. As you can see in this characteristic, if we are changing the output voltage, but the characteristic remains constant at a level of Is. If it is a 1 ampere source, then it would maintain the value of I naught at the level of 1 ampere at any value of output voltage. And the next property of ideal current source is the internal resistance of ideal current source is infinite. Now, practical current source. A practical current source consists of an ideal current source in parallel with an internal resistance. As you can see in the symbol of ideal current source, it is different from the ideal current source. In the practical current source, it consists ideal current source and a parallel resistance. In case of ideal current source, the internal resistance of ideal current source is infinite, but in this case, it exists. That's why the level of output current cannot remain constant at any value of output voltage. As you can see, the characteristic of this practical current source, we are here plotting the characteristic of practical current source by red color and the characteristic of ideal current source by the dotted lines. As you can see that the output current remains constant at any value of output voltage in case of ideal current source. But if we talk about the practical current source, then the output current decreases with the increase in output voltage. Now, it can also subdivided, voltage source and current sources are also subdivided into various categories. That independent sources, we have already discussed about the independent sources. It consists ideal sources and practical sources. The next category of such type of sources are dependent sources. Dependent sources are those sources in which the strength of voltage or current changes in the source for any change in the connected network. Such type of sources can be subdivided into 4 categories. These are the various type of dependent sources. Firstly, 2 are the dependent voltage source. The dependent sources are symbolized by using the diamond shapes. As you can see, these in these symbols, we have used the diamond shapes. In these diamond shapes, if we are putting the plus minus, then it would be dependent voltage source. If we are putting an arrow inside the diamond shape, then it would be dependent current source. Dependent voltage source can be dependent into 2 parameters. First one is voltage dependent voltage source. It means the dependent voltage source is depending on the voltage parameters of any other source, while in this symbol, this one is current dependent voltage source. The dependent voltage source is depending on the current level of any other element. That's why this one is called current dependent voltage source. The next one is voltage dependent current source. This one is the dependent current source. As you can see, an arrow inside the diamond shape, and here we have written the beta Vx. It means the dependent current source is depending on the voltage of any other source, while in this symbol, this one is current dependent current source. These are the reference books. Thank you.